Okay, so we're going to continue on from the previous video, which we looked at set notation, and we're going to analyse conditional probability. So what is conditional probability? Well, the language is slightly different. Conditional probability defines the probability of an event depending on what's happened previously. So a really simple example would be, what's the probability of someone turning up late to college given that their bus was late? Okay, so the language is different here. You'll see expressions like this: P, A, and a line and B. What does that actually mean? Well, this means, what's the probability of A? The line means given, and then B means B has occurred. So what's the probability of A given B has occurred? And you've got to make sure that you analyse all these questions properly when it comes to this sort of stuff, and make sure you understand what has actually occurred before you find a probability. So there is a formula that we'll look at later on, and it deals with this. And this is a formula which can help you get any conditional probability, and you can edit this formula as per your needs. So this is the formula here: probability A given B has occurred is equal to the probability of A and B divided by the probability of B. Okay, so it basically means the intersection between the two events and the probability of B. So in other words, find the probability of B first, of that event happening first, and then the probability of A given A on top of that. And you can change that formula to anything. If you had C, D, as long as you have the letters in the correct place, you can adapt this formula. What happens if you've got independent events? Well, if you remember in the previous video, events are independent when they have no bearing on each other. So when you've got independent events, then the probability of A given B, that's just going to be the probability of A, because the events are independent. There's no given, there's no probability of A happening given B, because they're independent. They don't have that link with each other to affect each other in that way. So that is something you need to remember. If events are independent, the probability of A given B is just the probability of A. And you can use that as a sort of a test as well, to test independence. So that's the basics. Right, let's just do these two questions on the worksheet, and then we'll see what we get up to. So we've got a small sixth form of 50 students. Maths and English are the two most popular subjects. I'm going to underline a few things. It's a very small sixth form, 50 students are there, 30 students study maths, 25 students studying English, and 10 students study both. Find the probability that a student studies maths given that he or she studies English. Right, looking at this, I can see that there's going to be a Venn diagram situation here, because we've got overlapping events. So I'm going to draw a Venn diagram. Maths, English. Okay. Now, when you have Venn diagrams, the most important thing to fill in is the intersection, and they've given you the intersection. There's a number of students who study maths and English, so I'm going to put 10 right here in the middle. If 10's in the middle and the whole circle of M represents 30, then obviously this will be 20. And if the whole circle of E represents 25, then this will be 15. Obviously the whole box and everything in it must add up to 50, and you can calculate that and you get 5 on the outside. Okay, so what's the question? The question is, what is the probability that a student studies maths given that they study English? Okay, so there are two ways to go about this. Either you can do it literally by looking at the Venn diagram and analysing it, or you can use the formula. I'm going to use the Venn diagram, just analyse it very quickly. Whenever I have Venn diagram questions and I've got to conditional probability, I always look at the second letter. I think, what's the probability of that happening first? Well, probability of English, well, that's going to be 25. There's 25 students that study English. And out of that, how many study maths? 10. So the probability of someone studying maths, given that they study English, is going to be 10 out of 25. How could I use the formula? Well, what I could do is I could look at if I want M line E, I can adapt this formula here, A and B. So I've got M and E, and I've got the second letter is E, second letter is B, so I'm going to have probability of E. Now, what's the probability of M and E? What's the probability of Maths and English? Well, it's 10 over 50. And what's the probability of studying English? Well, that's just 25 over 50. Okay, and if you work that out, you get the same answer. 10 out of 25. Okay, so that is that question there. Now we've got question 2. It looks like this. So we've got two events, M and Y. Probability of M is 0.23, probability of Y is 0.45, and probability of M and Y is 0.12. And based on that information, we've got to find these probabilities. Now again, I can see that if I've got probability of M and Y, that must suggest an overlap. So I'm going to do another Venn diagram. M, Y. Now I know what the intersection is. It's 0.12. Put that there. And obviously with a bit of quick mathematics you can fill in the rest. Okay. So that's not too difficult. What's the first question? What's the probability of M or Y or both? Okay, so if you remember from the previous video, that is the union, so it's basically everything here and here, all the two circles and the intersection. Okay, and if you add up those numbers, you get 0.56. Okay, or if you take 1 away from 0.44. Well, the next question, what's the probability of M given that Y has occurred? So what's the probability of M given that Y has occurred? So again, I could use my formula to do this as well. So probability of M and Y over the probability of Y. And I know what the probability of M and Y is. I know what the probability of Y is. Four, 5, which is 12 over 45. Okay, so that's the answer for those two. Now we've got the last two questions, which look a little bit funny, but if you just break it down slowly, it's not too difficult. So we've got here, what's the probability of Y given M has already occurred? So if you look at the previous question, we had probability of M given Y has occurred. Now we've got probability of Y given M's occurred. Okay, but we can still use the formula. So what's the probability of Y and M over the probability of M? Okay, probability of Y and M is the same as probability of M and Y, and the probability of M is 0.23. Which is 12 over 23. Okay, so that's there. And then we've got the final question, which is D. What's the probability of M given Y did not occur? So what's the probability of M given not Y? Again, you can edit the formula given to you. What's the probability of M and not Y over the probability of not Y? Right, now we've got to look at the knowledge from the previous video. What's the probability of M and not Y? So probability of M is 0.11. I don't want anything in Y here or here, so it's just 0.11. It's the intersection. Yeah, probability of M and not Y over the probability of not Y, which is 1 minus 0.45, which is 0.55, which is 11 over 55. Okay, so that's conditional probability, and you can see it builds on the knowledge from the set notation, and obviously looking at Venn diagrams and using this formula here, okay, which you'll see more of later on. Right, so in terms of the exercises for you to have a go at, we've got exercise 2b, page 23, and exercise 2c, page 25, which you can use to practice with. That's conditional probability.